the derivative of sine x is cosine x. So if I say f of x is sine x, then its derivative, f dash of x, is cosine x. Sometimes we see it like this, d dx of sine x, and we will write cosine x. The derivative of sine x is cosine x. Here is the graph of y equals sine x, and we're trying to figure out why is the derivative of sine x cosine x? The derivative of sine x is equal to cosine x. Why? Well, don't forget, when we find the derivative, when we're saying y prime is cosine x, well, we're finding, when we do this derivative, we're finding the slope of the tangent. So the first thing I want to talk about is, what about the slope of the tangent right there and right there? Hopefully you can see that we have horizontal tangent lines. Horizontal. Our tangent lines are horizontal. And what is the implication of horizontal tangent lines? The slope of the tangent line, also known as the derivative, is equal to 0 there. And if this is a horizontal tangent line, the slope of the tangent line is equal to 0 there. So if I'm asked to graph the derivative, now I'm graphing m tangent. Notice here where I'm graphing, if I change my y-axis from, as it was for the sine function, y, if I change it to y prime and graph my blue graph, if the derivative, also known as m tangent, the slope of the tangent, is 0, I'll graph it here. So where our m tangent is 0, there it is, I'm graphing the slope. I put a point here. Where my derivative is 0, my slope, my tangent is 0. So I'm putting it on my 0 line. The function value is 0. Here, if the slope is positive, I'll put it above the line. If the slope is negative, I'll put it below the line. Well, look at my slopes here. My slopes are highly positive, a little less positive, a little less positive, and almost 0. My slopes go from highly positive to less positive to less positive to 0. What does that look like? Like this, highly positive all the way down to 0. Now, if this were, let's just imagine you're at Universal Studios. I don't want to infringe on any trademarks here. And you're on that Hulk ride. So there you are in that little green car. Can you see that right here, our slope of our tangent is most negative? Our rise over run right there is most negative. So if I'm talking about the graph of the slope of the tangent or the derivative, right there it's going to be most negative, and we'll put it down here. We know it goes to 0 there. How about if our little green car comes all the way over to here? Notice the slope of the tangent right here. Look at these tangent lines. They're extremely positive. Well, I graph positive above the line. I'm most positive right there. Look at the blue graph. Max, 0, min, 0, max. What is that? That is the cosine curve. That's the cosine curve. That curve is the cosine curve. So you can see graphically, the derivative of sine is cosine. Here, if I asked you to do some examples, finding the derivative, if f of x equals sine x, we just saw the derivative f dash of x is cosine x. We're asked here, d dx of 5 sine x. This is saying to you, find the derivative. Well, we can think of this as 5, and then I pull that out, 5 times the derivative of sine x. The constant doesn't really affect it. We can pull that constant out. So you can see that it'll be 5 cosine of x. Negative 7. Well, f dash of x will be negative 7. times the derivative of sine x, which is cosine x. So do I really need these parentheses? No. Look at that constant just comes along for the ride. I could think of this as -1 times the derivative of sine x, which will be negative times cosine x. Here, 3 over 2 times sine x is going to give us 3 over 2. When we find the derivative, it'll give us 3 over 2 times the derivative of sine x, which is cosine of x. Of course, we could think of this as 4 over 5 times the derivative of sine x, which would give us 4 over 5 cosine of x. The derivative of square root of sine x, f dash of x here, would be, well, this constant will just be our multiplier outside, and the derivative of sine x is cosine x. Finally, ddx of sine x over 10, well, think of this as 1 over 10 times the derivative of sine x, which of course is 1 over 10 cosine x, or if you wanted to write cosine x over 10, that'd be fine as well.